हाँ। नहीं। हेलो। 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 बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वाहलुल उक़दतन मिन लिसानी यफ़क़हू क़ौली। Oh God, help me in my deliverance. Uh, this example is 3.3, and let's look what does it require. I'm trying to go through the statement very quickly. The curve has initial and final grades of 3% and -4%, meaning it's a crest curve, and it is 700 feet long. The elevation at the commencement of the curve is 100 feet. We need to graph the vertical curve elevation and slope of the curve against the length of the curve. Compute the K value and use it to locate the highest point of the curve, that is distance from point versus point of commencement of vertical curve. Uh, it's just a simple explanation, though I will not be covering the graph between vertical curve and the slope. I'll be just trying to explain you how this K is determined. So let's look at the data, summarize the data. G1 3%, G2 -4%, length, the rate, elevation at the points of commencement of vertical curve, 100 feet, and we need to know the value of K and X, the distance of the highest point of the curve. So let's come to the solution. Before the solution, we have a diagram. That's how the curve look like, and the origin is at start of the curve, x and y. The general formula is ax square elevation at any point along the curve y is ax square plus bx plus c. And a, we know that the difference of the grades divided by twice the length of the curve. B is the gradient 1, and c is elevation at the point of commencement of the vertical curve. We also know that the length of the curve is k times a, and a is the addition of the grades irrespective of the sign and multiply by 100 sometime. It's most of the time because if you take G1, normally we take it in terms of percent. So that what you need to do. This is that I have adopted a different formula so that some students sometimes do confused what to write between at G1. They don't write an absolute value. They write divided by 100, and that's why some more time when they calculate the length of the curve, uh, the length of the curve is 100 times what it should be. So it's here I've clarified the equation in such a manner. For instance, if I say G1, I say 3%, so 3%, it is 0.03. G2 is minus 0.04. It's because it's 4%, but the value is 0.04. But what I'm trying to say is you have to write 0.03 here, minus 0.04 here, then add it and multiply by 100. The point or the lowest point of the curve, there are two ways. One is uh, if you find out the slope, uh, this uh, is anything that has a highest point has a slope 0. That's why we find that the first derivative of the general equation as given in 1, y is equal to ax square plus bx plus c. And when we find the derivative and we say, and since the first derivative is 0, and then we determine the value of x just by simply solving the algebraic equation. Now the solution, we know A, we find this numerical value, that's into minus 5 into 10 power minus 5. B 0.03, C is equal to 100, A is equal to 700, and then we know that K is the length of the curve divided by A, and that's the value of K is 100 feet. This will be, helpful in also determining the lowest point of the curve as well, or highest point of the. So for the highest point of the curve, I've adopted the simple equation, though in the question it was not required to find it like this, but I've adopted always the same approach. So dy by dx is equal to 2ax plus b. We know the value of a, we know the value of b, and we know dy by dx is equal to 0. So when we substitute, we'll find x is equal to 300 feet. So the lowest point of the curve is x is 300 feet. The highest point of the curve is 300 feet from the curve. So logically, if you know the length of the curve, it's around, it's on the, it's on the, just before the, uh, just before the half of the curve, because half the curve is here. So the value is before a PVI, as you can see. So that's it for this example. We'll have another example solved in the next video. Take care.